We have started. I have started. I am thinking that all of you are ready. Let's explore this lecture. We selected lecture name is light. We will start from scratch and we will end till the advance. Okay. Uh, After understanding concepts, we will have some question and we will see some questions so that we can see, yeah, these are challenges, challenges, this type of questions are there in this. uh, so in this you are crystal clear that yes, name of this lecture is a light introduction. We will start from scratch. We will have a lot of topics. Nothing topic will be ignored. Okay, every topic, each topic, if those topics are important, then those topics will be covered with you. Yeah, concepts plus question, that's it. Remember, we will understand. Okay, we will understand. Our focus will be on discussion. We will pick up any random topic, not random topic. Whatever will be given topics by this lecture, then we will pick that topic and then we will start discussion. Now I want to start. We are starting with meaning of light, and then we will see laws of reflection. We are we are familiar. We all people are familiar with this, but it will be revision. Now we have started. Here you can see there is a figure. Here is a figure. Here, what is it telling you? What is it telling you? It is telling you a dark area. A dark area. Look, can you tell me, is there any light? No. Is there any light? No. But behind this person you can see light. Light. Light is coming, that's why you are able to see that yes, there is a person. But here can be something, but we don't know because of light is not falling on this. So that in this we are understanding importance of having light. If in a room there is a light, then we can see objects that are kept in that room. Even you can see, even you don't even you cannot see color of the wall of this room because of a lack of there is no light, that's why. And here you are able to see this person, not completely, but yeah, your mind is telling to you that yes, this is a person. How are you able to say that yes, this is a person? Because of light is falling on this, that's why we can clearly see this light, but this is not light. Okay, so to see anything we need anything. Okay, whatever. Even you are observing me, even you are looking me, even you are uh, watching me, I am able to see. You are able to see me because of there are a lot of, even one bulb is glowing and sunlight is falling on me. It can be source light, it can be natural light, it can be artificial light. Okay, one bulb is glowing and this light which is falling on my face. This is this light is coming is of a sun. This is sunlight which is falling on my face. You can see what I am saying. I am saying that you are able to see me because of light is falling on me. That's why. That's why. Now next, what is happening over here? This figure is telling you are able to see everything in this figure because reason is that light is falling everywhere, even source sunlight is coming here. This is a what you can say window, which is a glass window. From this through this glass window, source light sunlight is able to come in this house, and this whole house is fulfilled with light. In this we are not able to see because of there is no facilities of light. In this, if sunlight is coming, there can be artificial light. And here rays of a sun are falling in different direction, wherever they are falling on the surface, that surface of the object will be visible. Now look at here you know that this is nothing but it is a sunlight which is coming, and this is direction. Here you can see some but it is a little black. Why? Because some little amount of this sunlight is falling here, and here completely it is going completely. So this is a completely light, and this is a little bit light. The reason is that this side it is falling very late, very less. There is a less amount of sunlight here. This is what is the reason. Now here what is happening over here? This is sunlight is falling everywhere. Wherever this sunlight will fall, that object, we can see that object. Now look at here it is what shadow, not shadow but little black. Okay, little black because of what is the angle of sunlight matters. Okay, it matters. This sun is behind this house, and you will see what completely light behind of this house, because of it is directly falling. It will be direct, this sunlight will be directly falling on this behind this house, but it is not directly falling in front of this, because of this is behind this house. That's why. Okay, now in this, let's see. Here you can see, you are able to see everything. Yeah, here what is happening when he throws this, then out. When he throws this, then what happens? It takes back step. This football takes back step. Similar reflection of light works. When light will be coming from source light, then it will some rays of light will fall on the surface of the object, then it will turn into another direction. Just bouncing back of light is a reflection of light. Here is this is sunlight. Some sunlight will fall on this object, then it will turn into another direction. Some light will turn into another direction, some light will go in this direction, some in this direction, in this direction. It can go any direction. We are here, and some light will fall on this, then again it will take turn into another direction. Some light will reach to our eyes, and this is what is a process of seeing any object. Reflection of light. So this bouncing back, I am not talking about this reflection. A reflection of light is a reflection of light, a ray which is coming after hitting the surface. After hitting the surface, it does not come directly from the sunlight, from the source light. Okay, from the source light, it comes after hitting the surface. Now observer, this is observer. Here we are observing sun is falling on this object, then it is a after hitting this, it is a turning into another direction. This a turning ray is a reflection of light, and this some ray will reach to our eyes, then our in the at the retina a image will be formed. Then our mind would say, yes, this is what, this is a fruit, this is something, this is object. This is a process of seeing any object. First we need source light, second we need an object that we are going to see, then we need a observer, a human. We know that what is a work of our eye. At the retina uh, forms image, then it converts light into an electrical signal to send to our mind, so that our mind can say, yes, this is what the name of this object is, this color of this object is this whole process. Now activity. Here there is a one twist here. One twist is that this is window. Here is a little part of the window is broken. A little part of the window is broken, and from this broken part of the window, is sunlight is able to come. Okay, the sunlight is able to come from the outside into into inside the house. Now there is a wood in front of this. Here this is able to, this sunlight is able to come, but it is not able to pass through this. It is not able to pass through this, we can clearly see. So what is the reason behind this? Reason is that this wood is an opaque object. This is what is reason. Opaque object does not allow to light to pass. Yeah, transparent object will allow, but opaque object will not allow. Yeah, opaque object. Reason why that? Opaque object. Clear? Opaque object never will allow the light through them. Look at here. More points can be understood from this. When light will be coming from source light, we know that this is a source light. This light is coming from this source light. We are familiar. It is a falling on this surface, but it is not passing through this. It is not passing through this object. Rather than passing, it is a turning into. It will be turning into another direction, like that, like that. So this turning is a reflection of light. You are crystal clear. Now, remember always, if a object is blocking a light, if a object is blocking a light, okay, then that object will form shadow. Reason is that light is not light is not passing through the object. That's why shadow will be formed by that object. If light is passing through that object, then then that object will not form shadow. Remember, crystal clear. From this we understood how does shadow form. We understood meaning of opaque object. We understood reflection of light. Okay. Yeah. Source light. About source light. Source light. I would like to explain more. Is that source light? No. Uh, there are two types of a source light. First is natural light and second is artificial light. Both are very simple to understand it. I want to explain it because it will matter sometimes. Sometimes it will matter. Nature, which means nature. We are talking about nature light. Okay. So any kind of light you are taking, if those are made by nature, for example, star, all these are nature. Okay. And light is coming from this sun or star, then this type of source light we will consider it as a nature. Okay. When it will come to artificial light, then here we need to think. Don't think. Okay, don't think more. Artificial, which means we human are creating. Human are creating. Okay? A light is created by human. The source light is being created by human is named as a artificial light. For example, this a torch, a bulb. There are a lot of things that are made by human. So anything which is made by human will be known as artificial material. But here our context is that okay, source light. So any light which is made by human will be known as artificial light. Clear? Yeah, crystal clear. In this, what is happening? Look at here. This is a window, which is a glass window. We are able to see. We are able to see object area behind this wall, behind this window, because of this glass is a transparent. And here this wall, behind this wall we are not able to see behind this wall area. Behind this wall we are not able to see because of this is blocking the light, that's why. But it is not blocking the light. Okay. And remember, this will be for what? Shadow. Light can pass through transparent material. Yeah, we know. Here we have candle. Candle. In this you will understand direction of light. Direction of light. Look at it. This children is looking this candle by using this bent pipe. Will he be able to see? Yeah, little, but not completely. Not completely. Remember, it is not complex. Light direction of light is always straight. Direction of light is always straight. Always straight. Here, in this case, he will not be able to see this candle. But in this case, this he will be able to see the candle because of this pipe is straight. Here, pipe is bent, and inside the pipe, light will be traveling straight. Yeah, this he is able to see. He will be able to see to till here. But what about this? But in this, what is happening? He is able to see completely like that, completely, completely. Now, ahead of it. So what is happening over here? In this, light is coming, but it is light is able to go to till here, and it turned into like that. But in this, it is going light is going directly straight like that. Okay, yeah. Person is not able to see the light of the candle because of this bending. Yeah, we know. Okay. Laws of reflection of light. We are crystal clear that just bouncing back of light is a reflection of light. Turning direction of light. Here, there is a one activity. Uh, Sunlight is coming, and there is a person who is in his hand. There is a mirror. Here you can see he used a mirror, okay, a mirror material, and by using mirror material, this mirror is able to turn this sunlight into this direction. The sunlight was going like that, and this person turned this direction into like that. So it became possible when mirror was used then. When mirror was used then. In this, you can easily see what is happening over here. This mirror is opaque, it is not transparent. Why? Because behind this mirror, you can see this is a coated area. It is a painted area, you can say. That's why. And this a direction. This is a reflection. I am not talking about this. This will be known as incidence because it is coming from the source light. That's why. So a ray which is coming from the source light till the surface of the object will be known as incidence. But when it will come to reflection, then a ray which is coming after hitting the surface, here you can, this is coming after hitting this mirror. So this will be known as a reflection of light. Laws of reflection of light. There are two laws. First would be what? I angle of incidence will be equal to angle of reflection. Here you can see there is a one torch. It is coming. This is sun. This ray is coming like that. There is a mirror. Now what will happen? Now what will happen? It will turn into another light. Just to observe direction of light. It is coming like that. This is the direction of light. Okay. Now next it will go in this direction because of mirror. Look at here. It is telling me that from here to till here, from here to till here, a ray which is coming from this source light and to till here will be known as incidence. Clear? So this exact this strike point will be what? Point of incidence. And from here to till here, this will be known as incident reflector ray. We take a normal line which would be perpendicular. We will take it so that we can calculate angle whatever we want to calculate. Okay. Yeah, it is a imaginary line. Okay, it is a imaginary line, but remember this should be perpendicular. Normal line should be perpendicular. Now look at here. We know that this side it is making 90 degree and this side it is making 90 degree. First law for reflection of light says that IR angle of incidence. Where is the angle of incidence? So we are talking about this incidence from here to till here, not from surface, from angle of incidence till the normal line. This angle will be equal to this angle. This angle. Clear? Okay. This was the first law of reflection of light. Okay. Clear? So incidence ray will be represented by just a small letter I. Next R. This R is for this. Now what is happening over here? Second laws of reflection of light says that this incidence ray, reflector ray, and normal line, all these three will lie on the surface, on the surface. All this, not one will be another surface, second will be on another surface of the object. No, all this will lie on one surface of the object. Yeah, we know. So this is the first law of reflection of light. Now second laws. We are crystal clear. This is for you. Image formed by plane mirror. Image formed by plane mirror. We have all these topics. We are crystal clear about light and laws of refraction. Now we are going to explore plane mirror. Then we will explore spherical mirrors and its properties. Yes, this is also important. It is very necessary. After completing this, we will see concave mirror and its use, then convex mirror and its use, then mirror formula and magnification. I think after completing this, we will see refraction. I think so. Let's move. Yeah, here look at here. This is a plane mirror. Here, a plane mirror is a mirror with a flat reflective surface. This is, this should not be outward and inward. It should be just a flat. Okay, just a flat, equal flat, equal flat. Here you can see. This is a flat reflective surface, and this side is uh, a reflective surface. Here, look at here. Let's assume that this is you and this is mirror. Behind this mirror is a quoted area. Quoted area, which means painted area. It will be known as opaque object. Now, what will happen if you are in front of a plane mirror? Then your image will be formed inside the plane mirror. Will it happen or not? Yes, of course it will happen, because this is the work of a mirror. Okay. Okay. What is the process of seeing our image, our duplicate image inside the mirror? Process is that light will be falling on this. Light will be falling. Light will be going like that. Then it will go. It will stack here. Then like that, like that, like that, like that, like that. And that is how our image will be inside the inside the mirror. It's all about light. Clear? Now we know that we have a plane mirror, so nothing will be this that. Okay, everything will be exact same. Our size is let's just say 5 inch. Then inside the mirror will be same 5 inch. Size of the image will be 5 inch. We are whatever is the shape of us will be same. Shape of this will not be changed inside the mirror. Shape will be same. Shape of the image will be same as object. Okay. Yeah, one thing can be observed is that left side of the human, this left hand will appear in a right side inside the mirror, and this left hand will appear in a right side inside the mirror. This will happen. It is a nature. Remember, we are erect which means just upright. There is nothing a change in the size of the object. Erect image would be erect. Virtual image would be virtual because of this is imaginary. Imagine image. It is not a real image. Okay, this image is being formed inside the mirror. That's why we are saying that this is what it is, a virtual image, because it cannot be obtained on a screen. That's why. Look at here, what is happening over here. It is a visualization. A mirror image in a plane mirror is a reflected duplication of an object. Here this is a person. It is a original object. It is a original object because of this is a quoted area, and it is a image. This is a duplicate image of this, and here you can see what's the difference between this. Difference is nothing. You can see nothing. This distance of this distance of this object from this mirror is same as this between distance between this image and mirror. They are same. Clear? This would be known as image and this would be known as object. Okay, we are crystal clear. Now next. Yeah, we can see. Head, feet. Yeah, it is completely as it. Front of mirror, back of mirror. Yeah, we know. Object would be in front of mirror and image would be a back of mirror. Clear? Yeah. Virtual image, because of a virtual image cannot be projected onto a screen and it always falls behind the mirror. Yeah, I have told you. Next, yeah, size, you can see I have told you there would not be any change in size of the image. Okay, size would be same. If size of the object is a 4 inch, then size of the image would be same 4 inch. That's why we are saying that image is erect. Distance, you can see if distance is a 3 centimeter, distance between object and mirror is a 3 centimeter, would be same for image between image and a mirror would be same 3 centimeter. Now here I was talking about this right hand. This is for you, I have told you. It is known as laterally inverted. Okay, let me explain again. Here it is telling you left hand will appear in a right side inside the mirror. Right hand of the object will appear in the left side inside the mirror. If this is happening, this will be known as laterally inverted. Laterally inverted. That's it. Now here you can see ambulance word is the written, which is in a strange, which is in a strange. Why like that? The reason is that in front of this, ahead of this vehicle will be able to see in his mirror, side mirror, in his side mirror, that yes, ambulance is coming. So strange word if is written and it is in front of mirror, then it will be what? It will be correct. It will be unstrange in front of a mirror. That's why we are saying that it will be this plane mirror will give you laterally inverted. Letters sometimes will look like that. It happens. It happens. Here you can see. In the image, ambulance will be correct. The spelling of the ambulance will be correct. Yeah, we know that this is written on the object is in a strange, but when it will come in front of the mirror, then it will be in correct manner, because this is the nature of the uh, mirror. That's all. Calculation of every activity. Image is erect and virtual size of the image. This is for you. Yeah. spherical mirrors. Now we are here. Spherical mirrors. This is a spherical mirrors. It is not a spherical mirrors, but I am talking about shape. Shape. It is. This is a shape of a sphere. When we will cut this, then we will get two parts of this. So first part, name of the first part will be something else, and name of the other part will be something else. Let's see here. Try to observe this. it is a it is a inward, not outward. This is a inward. Here we know that this is outward, but this, in front of this is what, this is a inward. Okay, we know. And now this is a outward. Now this is a outward. Here you can see. So this would be inward and this would be outward. Yeah, outward. Concave side and convex side. Curved mirrors. Curved mirrors. A spherical mirrors, we will take a spherical mirror, then we will cut that spherical mirror so that we can get two parts of that spherical mirror. First we will have convex mirror, then second we will have concave mirror. Concave mirror. Here in this, what are you observing? At the center, this will be known as the curvature of this. This is the center of the curvature. We know this complete would be known as a sphere. And we are taking these two parts. This first and this is second. This first and this is second. We know that this from the center to till here, this is nothing but this is just a radius. Yeah, we know, we are crystal clear. From here to till here, this is a radius. From here to till here, this is known as a diameter. A spherical mirror is a mirror which has a curved reflecting surface. Curved reflecting surface. Hollow glass, a reflecting surface. So it is telling me that this is a reflecting surface. This here we are taking this reflecting surface and this as a coated area. This as a coated area, and this we are taking this as a reflecting surface. Now look at here. If a surface, a reflecting surface, not surface, okay, not a surface. If a reflecting surface is inward, that will be known as a concave. That will be known as a concave. If a reflective surface is inward, then that surface, that part of the spherical mirror will be known as concave mirror. Clear? And outward surface of that will be coated area. Clear? Okay, clear. We are clear. This is nothing but center of the curvature, and this is a pole. Pole at this between this. Just opposite of this would be what? Convex. Here in this case, what is happening here? We are taking this as a coated area. Okay, coated area. So remember, If a reflecting surface is a outward. If a reflecting surface is outward, then that part of the spherical mirror will be known as a convex mirror because of outward part is the reflecting surface. That's why. Till here we saw that what is a spherical mirror and what is a concave mirror, what is a convex mirror. We have seen concave is just inward surface would be reflecting surface, and convex mirror would say that outward surface would be a reflecting surface. Here you can see this is what it is a inward. So when it comes to inwards, we say that yeah, this is a concave. Just opposite this would be convex mirror. Okay, so this opposite this behind this is what convex. Here you can see this would be known as convex mirror. With this material we are understanding two types of mirror, convex and concave. This side is a concave and behind this is a convex. Now this is for you, a mirror who has a reflective surface is a curve. This is for you. Now properties of a spherical mirror. Properties. Convex mirror, okay, concave mirror. What is happening over here? A ray is coming directly parallel to the principal axis. Convex mirror, we have convex mirror. Here a ray is coming parallel to the principal axis, but remember it will turn, this will turn into another direction, like that. It is not parallel. This reflected ray is not parallel. Second ray is coming, but it is also not a parallel. It is not a parallel. In the case of a concave, here it is going a parallel, but reflected ray is turning into another direction, and it is passing through the focus. Same with this. Concave, I think it is also known as converging. I am not confirmed. What is a pole? Pole is nothing but just at the center of the between this mirror. This between will be known as pole. The center of the reflective surface. The center of the reflective surface, yes, of the spherical mirror is a point. This point will be the point. The center of the reflecting surface will be point. Clear? Now next, center of a curvature. Yeah, this is the center of a curvature. Now next we have this is known as what? We know that this is nothing but concave. This is nothing but concave. Yeah, we know. Now next, this side would be convex. These are two parts of the spherical mirrors. Okay, we took these two parts of the spherical mirror from the sphere. A spherical mirror. Look at here. This is CP. CP, I think it should be radius. Yes, this CP is a radius. Here we have this what? This is a circle, and we know that from the center till the circumference is nothing but just a radius. And half of this radius would be known as a focus. Half of this radius. Principal axis. This whole will be known as a principal axis, which will be intersecting the circumference of the spherical mirror. Principal axis, okay? Concave mirror. It is burnt because of light was converged. That's all. Properties of spherical mirrors. Here in this, try to understand. We know that this is nothing but principal axis, but remember, we are not taking from here to till pole. No, this is intersecting. It is intersecting the reflecting surface. A line which is intersecting the reflecting surface will be known as principal axis. Will be known as principal axis. Now next, look at it. Here what is happening in this? Two rays of light. Two rays of light. This first ray and this is second. Both are coming parallel. Okay, both are coming parallel to the principal axis. Now in the next, what will happen? If both are parallel, in the case of concave, both will converge, not diverge. Okay, both are converging and both are meeting at a focus. I think so. It is meeting at a focus. Remember, in the case of a concave, if both are parallel rays, so both rays are parallel, then both will meet at a focus. So this will be known as meeting. This intersection point. This will be known as principal focus. Principal focus. Clear? Converging mirror. Here we saw that both are converging after the hitting the concave mirror. That's why we are saying that this will be known as a converging mirror, because of both are converging. Both are being converged by this mirror. So this will be known as a converging mirror. Clear? Because we have a concave. That's why. Here reflecting surface is inward. So of course both will converge. Now in the case of a convex, if both are parallel to the principal axis, then what will happen? I think so it should diverge. Here you can see it is diverging, because of we have convex. Our outward surface is a reflecting surface. In this case, if both are diverging, then what will happen? We will have to do something. What we will have to retrace this like that, so that they can meet at a focus, and this will be known as what? In that case, this will form virtual image. Because it is a forming inside the mirror. Okay, not in front of mirror. this is imaginary. In this case, uh, image will be virtual, and this will be known as a principal axis, principal focus. Okay, this will be known as a principal focus. Clear? We know that this is nothing but focus length, FP, but CP would be radius. FP would be focal length. Yeah, this F, the next. Okay, this is making circle, principal focus. We will denote this focal length by just F. Here, aperture. This aperture means what is the amount of curving this? What is the amount of curved of this mirror? This is what is a aperture. A to B. Here we are crystal clear relation between radius of a curvature and focal length. We know that this focal length is a half of the radius. R is equal to 2f. This R would be equal to 2f. This one and this is second f. Yeah. Okay. We have seen this. Yeah, I know. Radius of a curvature. This will be known as the radius of the curvature. This is for you. The center of the reflecting surface. All this is for you. Even all this. The diameter of the reflecting surface of a spherical mirror is called its aperture. We have one question. If a radius of the curvature is 20 centimeter, then focal length would be 10 centimeter. Focal length would be 10 centimeter. Now we have cases of incidence rays on a spherical mirror. Look at here. This is object. Name of this object is a candle, and we have this concave mirror. This is a screen. This is a screen. We are going to visualize it. Here this is a concave mirror. We are starting from concave. We know that this inward is a reflective surface. Now in front of us we have a concave. In front of this concave mirror there is a this is a screen. Okay, and we have this candle. Look at here. It is at P pole, and this we have F, which is a focus, and this is a curvature. Now, where is the position of the object? This is beyond the center of the curvature. Yes, this is beyond of the center of the curvature. Now, in that case, what will happen? Let's see. Beyond C. Beyond C. Image formation by concave mirror. This is candle. Yeah. Height of the candle. Large number of rays generated by each point of the object will be like that. These are rays. Okay. Okay. So here, rather than taking all these rays, we will take an initial and final. Okay, just to understand, because there are a lot of. So just we will take two, one at upper and second at the bottom. So two rays we will take to understand. Look at here. Look at here. This one ray and this is second ray. This one ray and this is second ray. This is beyond this sea. What is happening over here? Both are parallel to the principal axis and both are meeting at a focal length. At a focal length. Focus. A ray parallel to the principal axis. Yeah, Vina. It after hitting the surface, it meets at focus. Yeah. In the case of the convex mirror, Vina, it diverges and it is retraced to the focus. Vina. What is happening with the both mirror? In this case, this is converging and this is a diverging. Both are meeting at a P, at a F, but it is a real, but this is a not real. It is a imaginary. So that's why this is a forming virtual and it is a forming real, because it is a, this intersection. This is in front of mirror and it is behind the mirror. It will be here, image will be real and this would be virtual. Ray passing through principal focus. A ray which is passing through the principal focus will be like that. It will go like that. It will go like that. Then this is not parallel. But when it will hit the surface, then it will become parallel. Same here. This ray which looks like it is going to pass the focus, but what happened? This again it takes a turn in the same direction as it was coming, and here it is retracing. So this is forming a virtual image. Okay. Now here what is happening? This is coming, but it is becoming parallel. This is coming like that, and it is becoming parallel. In both cases, both are meeting at a focus. Now, of a ray which is passing through the center of the curvature. Here what happens? It bounces back in the same direction. In that case, same here. Here you can see it is going like that. It is going to pass this center of the curvature, but what is happening? It is going again. It is going in this same direction, because of this was going to target the center of the curvature. Yeah. If a ray which is incidence ray, if incidence ray is going and reflected ray is coming again in the same direction. If this is happening, then you need to think that yes, it is happening because of the it is going perpendicularly. That's why it is going perpendicular. That's why. What if a ray which is a passing a ray which is a passing a pole? Then what will happen? In that case, we are familiar with this. This will go like that. This will go like that, and then it will take turn into this direction. And in this case, we know that this I is equal to R. This I is equal to R. Same here, it will come like that, then it will go like that. Here, in this also, I will be equal to R. Okay. Point of incidence. Yeah, you can see what's the difference between. We have seen this. Image formation by concave mirror. How many times? Principal axis, yeah, Vina. Principal axis, then, yeah, this is focus. What else? This is pole, yeah. This is the radius of the curvature, yes. Object at infinity. In the first case, object is at infinity, okay? Are you ready? In that case, what will happen? Object is at infinity. Then here, both two rays will come parallel to the principal axis. Then it will, here, look at here. We have concave. In that case, both will converge because of it is a converging mirror. So here, let's see. Yeah, both are converging. And after converging, both are meeting at a focus, principal focus. Now, image is real and inverted. Yeah, we know because this image is in front of mirror. It is not behind the mirror. That's why this is here, and it is inverted. Real will form. We know that real forms inverted mirror image. Now what else? Highly diminished and point size. Point size. Okay, it is telling you highly diminished. Very little. Very little. Diminished, which means a small, very small, and point size. What else? Now, in the other case, in the second, in the case of a second, object is between infinity and C. In the first case, we saw that object was at object was at infinity, but in this case we have a object which is between the infinity and center of the curvature. Now what will happen? We will take two rays. We will take two rays. Look at this. Here object, if object is between infinity and curvature, in that case one ray will go parallel to the principal axis, and then after hitting the surface it will pass the focus. Yeah, okay, it will pass the focus. Okay, then second ray, from here, it is passing the center of the curvature, and then it will hit the surface of the reflecting surface. It will hit here, remember, a reflecting surface, a ray which is passing the center curvature. Again it will, when it will take turn, then it will be coming in the same direction, because of it is passing the center of the curvature. That's why we have seen this. In that case you can say intersection view. This is the intersection view of these two rays. So at this point this image will be formed. So here we have a image which would be inverted. This would be inverted, and size you can see this is size. So it is a just a diminished size of the image is a diminished now. Okay, yes, this is what it is a image. I have told you. Image form between the radius of curvature. If object is beyond the center of the curvature, then position of the image will be between the center of the curvature and focus, principal focus. This will happen when position of the object is beyond this. Then image is real, yeah, now and inverted, yes, diminished, not highly diminished but little diminished. Yeah, what else? Now in the third case, object is at sea. In that case what will happen? A ray is going, yeah, then at second ray is passing this focus. What is happening? We know that a ray which is passing through the focus will become parallel after hitting the surface, and this was a parallel and it became this, like that, and both are meeting over here, approximately to the center of the curvature. Intersection view is over here. Yeah, object at sea. So object is at sea. If object is at sea, center of the curvature, then image will also be at sea, but it would be inverted. Image is real and inverted, but when it will come to in order to size, then we will say size is equal, same size. Now what if object is between C and F? In that case, okay, then one ray will go like that. It is passing this curvature. Of course it will take back step. like that. In that case, image is forming beyond the sea. Here, size of the image is high, more than object, because of object is between C and A. That's why. Yeah, images enlarged. Object at focus. In that case, what will happen? Let's say, if object at focus, then both will come back. What happened? Object at infinity. First of all, let's see what are image formation by concave mirror. We have seen this. We have seen this. Here, object at a focus. It will go like that, parallel. We know that it will become like that. What is happening? It is going like that. It is passing the center of the curvature. So here it is going passing the principal focus, and this is second ray is like that, and both are not meeting. So here image will be virtual. Image will be formed behind this mirror. Image form at infinity. This is for you. Object between focus and pole. Yeah. In that case also image will be virtual. Image should be virtual. Image should be virtual. Look at here. We know that if a object is between F and P, in that case, a ray will go like that. One ray will go like that, which will be I angle of incidence is equal to angle of refraction. We know that, and second is going like that. It is passing the center of the curvature. Now, what is happening over here? Both are not meeting. Both are not intersecting. Now, can we say that yes, image is very large, and yeah. Mm, so image will be virtual. We will have to retrace this like that, like that. Here both are meeting. Here both are meeting. So from here to till here, you can see size of the image is a large than this. In this, we saw that yes, image is becoming virtual. Image is becoming virtual because of both are not meeting. Both have to meet. Concave mirror. Erect, virtual, larger than object. Yes. Now, next we have, yeah, it is crystal clear. This is for you to remember. If we want to obtain erect and enlarged image of an object, where should the object be placed in front of a concave mirror? Yeah, we know that object should be uh, P, no, F and P, or at F. Object should be placed between pole of mirror and a focus to obtain erect and enlarged image of an object. We saw this right now. How can we forget? Forget. Yeah. Uses of a concave. Concave. Yeah, there are a lot of uses. Even people are using. Even doctors are using this. Doctor use this to see any little thing into large view. Everybody, anybody who is using this will be using for looking a tiny material into large view. This in this devices these are used to, yeah, I would say importance of this is very high. Okay, even we cannot see direct use of this in in solar plate. You can see use of this. There are a lot of but um, there are some examples that will be important to give you. This is first is torch, and second would be solar plate. In solar plate, this is used to be so that lights which is coming from sunlight can be converged. Okay, then that lights is being is converted into electricity, not completely electricity, but that light works like electricity. Okay, now second, this mirror, concave mirror, is used to see. Yeah, you know, you are familiar with this. In this, look at here, what happens over here? Light is this is light, but this is not complete light. This is a reflector. Around this light is a reflector. What is the work of reflector? When this light will fall on this reflector, then it will go direct instead. Here you can see this is going straight instead. Here bulb at focus, parallel rays. Here what is happening? Bulb at focus. Bulb is over here, and it is a some ray will fall here, and then it will go directly like that. Then it will this bulb, look at here, bulb is at focus, okay. In that case, what is happening? This ray will go here, this ray will go here, sun ray, and all this ray will become parallel. All these rays are becoming parallel. That is how it works. That is how it works. Parallel rays. Here you can see. This is at focus. It is at focus. And all the rays of this bulb is falling here. Here. You can see, you can visualize it. Some rays are falling on the reflector, and it is going like that. Parallel. That is how it works. Same with this. In searchlight, there is a use of a concave mirror. In this headlight, there is a use of a concave mirror. Now, okay, concave mirror again. We use it is used in many houses, in shops. Concave, yeah, yeah, we know. Here, look at here. What is happening over here? Light is coming, sunlight is coming and falling on this is here reflector is what is the reflector doing? All this is coming. This was a solar furnace. Image formation by convex.